Hello, this is the presentation of the survey paper titled Types of Transformers. It will give a detailed survey of a few types of transformers. Transformers are devices that converts alternating current electrical power at a voltage level to alternating current electrical power at another voltage level through a magnetic field. Nowadays, transformers are used widely and profoundly due to their ability to convert alternating current electrical power between voltage levels, as for example the voltage across transmission lines should be low so as to avoid power losses in them, so a transformer is used to convert the electrical power to a lower voltage level before entering the transmission lines and then switch back to the original voltage level using another transformer. Different transformers have been created for their respective different uses, and each one of them has been created some very long time ago while some quite recently, according to the specifications of their use, but for all transformers the basic purpose is still common, that is to convert alternating current electrical power from one voltage level to another. Pulse transformers of unique kinds of transformer utilized for electrical disengagement of two distinct circuits. This is a basic plan of moving the pulses starting with one then on to the next winding. DC pulse is required in the supply terminal. Its leeway is no other pulse is required in the auxiliary side of the transformer and can work decently with fast speed. The activity of the pulse transformer relies upon low spillage reactance and stray capacitance. By and large, it is a transformer utilized with pulse DC control. Quality of transmission of fast transients in pulse or wideband transformers depends on such parasitic parameters like resistive losses, leakage inductance, interwinding capacitance and winding self-capacitance. These parameters can be included in the equivalent circuit as shown in the figure, where N is the turn ratio of the transformer, R1 resistance of the primary winding, R2 resistance of the secondary winding referred to the primary side, RC resistance representing the core loss, leak 1 leakage inductance of the primary winding, leak 2 leakage inductance of the secondary winding referred to the primary side, M mutual inductance, C'11 distributed capacitance of the primary winding represented as a lumped capacitance, C'22 distributed capacitance of the secondary winding represented as a lumped capacitance, C'12 distributed interwinding capacitance, primary to secondary winding. Like most of know, there is an expert recording engineer present in the studio to make sure that music instruments and the voices make a perfect blend. A critical device that helps in creating this blend is an audio transformer. Works just like any other conventional transformer. Audio transformers are designed to work at audio frequencies, that is between 20 Hz to 20 kHz. Like any other transformer, audio transformer comprises of a primary winding, secondary winding in the core, and the primary function of an audio transformer is to couple the energy from the primary windings to the secondary without introducing any distortion. Audio transformers are used primarily in audio circuits. Audio transformers are designed to operate within the audio band of transformers, and as such can have applications in the input types of transformers, output stage, loudspeakers, interstage coupling, as well as impedance matching of amplifiers. A very common impedance matching application is for 100-volt line transformers for the transmission of music and voice over public address tannoy systems. These types of ceiling-based speaker systems use multiple loudspeakers located some distance from the power amplifier. Since the impedance of a typical loudspeaker is generally low, an impedance-matching step-down transformer, usually called a line-to-voice coil transformer, is used for each loudspeaker connected to the 100 volts line as shown. Here the amplifier uses a step-up transformer to provide a constant 100 volts transmission line voltage at reduced current, for a given power output. The loudspeakers are connected together in parallel, with each speaker having its own impedance-matching step-down transformer to reduce the secondary voltage and increase the current, thereby matching the 100 volts line to the low impedances of the loudspeakers. A resonant transformer is a transformer in which one or both windings has a capacitor across it and functions as a tuned circuit. Used at radio frequencies, resonant transformers can function as high Q-factor bandpass filters. The transformer windings have either air or ferrite cores, and the bandwidth can be adjusted by varying the coupling. They are used in radio transmitters, electronic ballasts for gas discharge lamps, high-voltage power supplies, and in some types of switching power supplies. A Tesla coil is most interesting resonant transformer. Resonant inductive coupling is a phenomenon with inductive coupling where the coupling becomes stronger when the secondary side of the loosely coupled coil resonates. A resonant transformer of this type is often used in analog circuits as a band-pass filter. Resonant inductive coupling is used in wireless power systems for portable computers, phones, and vehicles. Instrument transformers are typically used to operate instruments from high-voltage lines or high-current circuits, safely isolating measurement and control circuitry from the high voltages or currents. The primary winding of the transformer is connected to the high-voltage or high-current circuit, and the meter or relay is connected to the secondary circuit. Instrument transformers may also be used as an isolation transformer so that secondary quantities may be used without affecting the primary circuitry. There are two types of instrument transformer. Number 1, voltage or potential transformer. Number 2, current transformer. Voltage transformers, VT, also called potential transformers, PT, are a parallel connected type of instrument transformer, used for metering and protection in high-voltage circuits or faster phase shift isolation. They are designed to present negligible load to the supply being measured and to have an accurate voltage ratio to enable accurate metering. A potential transformer may have several secondary windings on the same core as a primary winding, for use in different metering or protection circuits. The primary may be connected phase to ground or phase to phase. The secondary is usually grounded on one terminal. These are used to step down the current levels so that ammeters, current coils of other instruments and relays need not be connected directly to the high-power operating circuit. Hence, all these instruments are isolated from high-power circuit. A current transformer consists of separate primary and secondary windings. The primary consists of one or a few turns of heavy wire wound on a laminated core. This winding is connected in series with one of the power lines. In some CTs, line conductor or wire itself serves